Hello everybody and welcome to my channel. Today we will solve several mechanics questions. So let's start with question number 1. For a cantilever, beam with concentrated load P applied at its free end. The moment at the fixed support, this is simply a question asking about, we have a cantilever of length L and a force is applied at its free end P. So the moment this force causes at the end, at the fixed end, is P, and that's simple. The distance multiplied by the force, so that's PL. So the answer is A, PL. The next question, a particle moving at constant speed in a circular path experiences acceleration that is. Now, when a particle moves in a circular path like this, so this is a circular path, this is the center, and the particle is moving at a constant velocity v. So there is an acceleration towards the center of the circle, and this is known as the v square over 2g. So this is the acceleration v square over 2g. So tangential to the circle, 0, since the speed is constant, directed outward from the center, directed toward the center of the circle. So the centrifugal acceleration is directed towards the center of the circle. So the answer is D, directed towards the center of the circle. Next question. In the analysis, if you remove this, in the analysis of a two-dimensional truss using the method of joints, it is assumed that the joints behave as rigid connections transmitting bending moments. So the joints, they don't transmit bending moments. So the assumption is that the joints are frictionless pins transmitting only axial forces. So this is an assumption in truss analysis. So you should remember this assumption. The joints are frictionless pins and they transmit only axial forces, either tension or compression. They don't transmit moments. The next question, when applying the method of sections in truss analysis, the ideal section should. So in truss analysis, when applied the method of sections, so the ideal cross section should cut exactly one unknown member, cut through no more than 3 members, exclude all support sections, pass only through members with known forces. So the ideal section should cut through a maximum of 3 members, 3 unknown members, because we have only 3 equations. So the correct answer is B. Now answer A, cut through exactly one unknown. It can cut through one unknown member. It should not be exactly one unknown member. It can be up to 3 unknown members because we have 3 equations, the equations of static equilibrium. So we can solve one section for 3 unknown forces in 3 members. Next question. Let me remove these. In dynamic analysis, the term dynamic amplification factor refers to, amplification refers to increase. Okay, so it should be something increasing. Now, the reduction of static load. So you can eliminate this option from the word reduction. The increase in load effects resulting from inertial forces during rapid loading. C, the ratio of structure's natural frequency to loading frequency. So C is not correct because it is a ratio of frequency to frequency. So it is not an increase in something. The energy dissipation, so dissipation is also a reduction. So by simply common sense, we can eliminate A, C, and D. So the correct answer is B. Next question about Poisson's ratio. So the Poisson ratio is defined as the negative ratio of lateral strain, the axial strain under uniaxial loading, which best option describes this. So it gave us the definition of Poisson ratio, which is the lateral strain to the longitudinal strain or the axial strain, and there is a negative sign. So the correct answer is yeah, A minus E lateral to epsilon lateral to epsilon axial. So this is the correct answer. So the correct answer is A. Next question. In bending moment beams, if moment and distance from the neutral axis are held constant, increasing the moment of inertia. Well, now moments on beams, it produces stress on the cross section. So this stress is determined by MC over I. So sigma in beams, stress as a result of a moment, applied moment sigma equals MC over I. This is very well-known formula, and this type of question, it repeats in the different PE exams. So you should understand this formula. So sigma along the cross section or over the cross section, this is the cross section, the stress varies. This is the center line. So the stress varies in the two directions as we go up and down, something like this. So one section there is tension and one section there is compression. In the upper section, there is compression, and the down the cross section there is tension. And this stress varies with the distance from the center line. So this is the equation that governs the relationship MC over I, where C is the distance from the center line upward or downward. Now the effect of I, this question is about if it asks about the effect of I, distance from the neutral axis is constant. So C is constant and the moment is constant. So increasing the moment of inertia. So if I increases, stress will decrease. So decrease the bending stress. So the correct answer is C. If the moment of inertia increases, so the moment, the stress from the bending moment will decrease. Again, there is always a question about this formula in the FE exam, so you should remember this, remember and understand this formula. The next question, which property of a material indicates the stress level at which it begins to deform plastically? Now, this is about the stress-strain relationship. Again, this question repeats in the FE exams, so you should understand the different points and the stress-strain relationship of ductile material. Now, you will not be given this drawing. I added this stress-strain relationship. So you should understand, you should memorize the memorize and understand the stress-strain drawing and its relation. So the point, a material indicates the stress level at which it begins to deform plastically. So the point where the material starts to deform plastically is the yield point, which is point B, the yield point. Now, elastic deformation, A is the elastic deformation. Now, elastic deformation means that when the load is removed, there isn't going to be any residual strains. The object will go back to its original shape. Now, beyond point A, at point B, now the material starts to deform plastically. So if the loading is removed, there is still going to be strain. So this is, so point B, the yield point, it is the point at which or beyond which the material will start to deform plastically. So it is the yield strength, B. The correct answer is B, yield strength. Now, next question. Again, about the stress-strain relationship. So the ultimate tensile strength of a material is determined at which point on the stress-strain curve. So the ultimate, we go back, I want to show you again the stress-strain relationship. So the ultimate stress is point E in the diagram. The ultimate stress is point E, this point. So this point is the point just before the failure or for a fracture, which is point F. So we go back to the question. So the ultimate tensile strength of a material is determined at which point of the stress-strain curve, at the initial linear portion, no, at the yield point, no, at the onset of necking, at the maximum stress prior to fracture. So this is the correct answer. So the ultimate stress is at the maximum stress before fracture. The next question, for a column under axial compressive load, what is the primary design consideration to prevent buckling? So to prevent buckling, material yielding, elastic instability, fatigue failure, and torsional distortion. So to prevent, the most important design criteria is the elastic instability. To prevent buckling is the elastic instability. It is not the material yielding. It is not fatigue. Fatigue is different, and it is not torsion. So it is the elastic instability. Next question. High hardness ratio, high slenderness ratio is in column indicates that it is. Now, there is a definition for the slenderness ratio, which is a factor or a constant KL over R. Slenderness ratio is defined as A L over R, where K is a factor that depends on the end support, and L is the length, and R is the radius. So KL over R. So high slenderness ratio, if this ratio is high, that means the column is subject to buckling, more subject to buckling. So less prone to buckling, high slenderness ratio, less prone to buckling, no, more likely to experience elastic buckling, adequately reinforced, has not to do with reinforcement, optimally designed for compression. So the correct answer is more likely to experience buckling. The higher KL over R the cylinderness ratio, the more the object or the column is subject to buckling. Now, cylinder reinforced concrete column under compressive loads are most susceptible to. Again, cylinder, that means its KL over I is high. Crushing failure, flexural buckling, torsional instability, shear cracking. So since it is cylinder, that means high KL over R, so we look for buckling. So it is subject to flexural buckling, to failure by flexural buckling. So next question. The design of continuous beam over multiple supports primarily aims to reduce bending moment, shear forces, deflections, axial loads. So the supports, when we use multiple supports, we reduce the span length, and that reduces deflection. So the correct answer is deflection. The main objective is to reduce deflection. The next question. In tension control reinforced concrete design, specifying the maximum reinforcement ratio ensures that. Now, when we reinforce a concrete section, now concrete is brittle and steel is elastic. That means that the failure of concrete is sudden. It does not give warning, while the failure of steel is not sudden, it takes time. It gives warning. So it will yield at the beginning for some time, it will then fail. So it gives warning. So the aim of specifying maximum steel ratio is to make sure that the failure will occur at the steel. It will not occur at the concrete. So here, if we look to the different options or choices, so choice B is the correct choice. So there is a maximum limit on the steel ratio so that the steel yields before the concrete crushes, ensuring ductile behavior. So that will ensure that the steel will fare before concrete. We increase the steel will stand, and the failure will occur in the concrete, and that will be sudden, it will not give warning. So we impose a maximum reinforcement ratio to make sure that failure occurs at the steel before the concrete. So the next question. So which statement about buckling in columns is true? Now, longer cylinder columns have higher critical loads than short columns. This is not correct. Because the higher the cylinder ratio, the column will become weaker. Buckling is independent of column ends condition. This is not correct. We say that there is a factor that determines, that depends on which is the K, depends on the end support. See, the Euler buckling load is inversely proportional to the square of the column effective length. This is possibly correct. Now, material yield strength has no effect on buckling performance. Now, the yield strength, it does not affect the buckling performance. So this is also not correct. So you can eliminate D, you can eliminate B, and you can eliminate A. So actually the correct answer is C. And there's a relationship between, which is the Euler, the load the column that can withstand, which is P critical, P critical equals pi square E I over KL squared. So this is the formula, this is the Euler formula, the critical load column subject to cylinders can handle, which has to do with we see that the critical load is inversely proportional to L squared here. So this is C is the correct answer. But if you don't remember the formula in the exam, we see that you can eliminate A, B, and D by coincidence. So that's all about today's video. If you have any question about the problems we solved in this video, please let me know in the comments. If you have any problem you want me to solve, please also send me in the comments. Thank you for following my channel, and I look forward to seeing you in the next videos.